Hey guys, so this video is going to focus on how to work the mixture problem. So the mixture problem is a somewhat familiar problem when it comes to application problems with solving the equations, and they typically read something like this. So this particular problem says that we have a chemist that must mix 8 liters of a 40% acid solution with some 70% solution to get a 50% solution. How much of the 70% solution should be used? Now, there is a formula that does go along with this problem, and it looks something like this. Percent times amount plus percent times amount is equal to, well, percent times amount. Okay, so what we need to do is we need to figure out how can we substitute into this formula in order to solve this equation. When it does come to word problems, the most important part of the word problems, in my opinion, is the setup from the beginning, making sure that you do set up the problem, you do input the right things. That way you do make sure that you are solving the appropriate equation after that, because if the problem starts off wrong, everything else you're going to do after that is not going to be right. So understanding how to set this up is the most important part of the problem. So we need to try and picture this for a second here. So we're in chemistry class and we have a solution, right, our first solution, and we're going to mix it with this second solution, right, into a third container. So we're taking one, we're taking a second one, and we're pouring it together to make this concoction that we need. All right, so that's what these three here are: the percent amount of the first solution, the percent amount of the second solution, and then our answer, the solution we're trying to get. So we need to try and plug in a percent and the amount of liters for these particular ones. So the first bit of information that they give us is that the chemist is mixing 8 liters of a 40% acid solution. They gave us the amount is 8 liters. They gave us the percent, that is 40%. So we're going to go ahead and use that to plug it into this first solution here. So the percent for this first solution is given at 40%. Typically when we do insert a percent into an equation, we do need to convert that percent to a decimal. So 40% as a decimal, to take a percent to a decimal, you move the decimal point over 2 times to the left. So 40% is 0.4. And the amount given is 8 liters. Then we're going to look at our second solution, and it says that we are mixing it with some 70% solution. So it doesn't give us an amount for it. It does give us the percent. It gives us that it's 70%. So 70% as a decimal is 0.7. And because we're not given an amount for that solution, let's just say that it's X. Okay, remember that X just represents a variable. It's an unknown. We have no idea how many liters are in that second solution. So the solution that we need for our end game here, it says that we want to get a 50% solution. So that's what we want our answer to be. So 50% as a decimal would be 0.5. And our amount here, this is probably the tricky part where a lot of people have problems here with this amount, because of course it doesn't tell us the amount of it. That's what the question is asking: how much of the 70% solution should be used? But you got to keep in mind that you're taking this first solution, mixing it with this second solution, and those two components are going to give you your answer here. So what you need to plug in for this amount over here is what you would get when you add the two amounts of the first and second solution. So the amount for the first solution is 8. The amount for the second solution is X. Just add those together. 8 liters plus however many liters I have over here is going to be how many liters I end up with. So our amount over here is going to be 8 plus X. We have this 8 liters over here plus this X amount of liters over here. And that's going to give us our solution here. So percent amount of the first one, 40% of 8 liters, plus 70% of some unknown amount of liters is going to give us a 50% solution of however many liters we got when we mixed the two together. Then after this point here, all we gotta do is go ahead and clean up this equation and solve it. So the first term that we have here, 0.4 times 8, that gives us 3.2, plus 0.7 times x is equal to, we need to distribute that 0.5 out, so 0.5 times 8 is equal to 4 plus 0.5 times x. So we need to clean this up a little bit here. So we do have two variables on either side. We have two numbers on either side. Remember, we need to isolate our variable, get our variable on one side, our number on the other. I'm going to subtract the 0.5x on both sides and move my variables to the left-hand side. That's going to make it cancel on the right-hand side. And on the left-hand side, I'm going to drop down the 3.2, and 0.7x minus 0.5x gives me 0.2x. And since I got my variable on the left-hand side, that means I'm going to move my number to the right-hand side, leaving me with 0.2x is equal to 0.8 here. And last step in solving this equation is to divide out the coefficient. So x is going to equal 4 when I do that division. 0.8 divided by 0.2 is 4. So we do need to go back up to our question and make sure we did solve for the correct thing. So this question says, how much of the 70% solution should be used? We need to try and figure out, did x represent the amount for the 70% solution? Remember that we plugged in x right up here in our problem, and that x is attached to the 0.7, so it is attached to the 70% solution. So that just means that we need 4 liters of the 70% solution along with 8 liters of the 40% solution, and that's what's going to give us our 50% solution that we're wanting. So for this particular problem, our answer is 4 liters. Otherwise, that's it for this video.